Okay folks, this is Dave from plastibots.com. Received a LISAMRC ML180 carbon fiber frame kit for a quadcopter from GearBest.com. So we're going to be doing an unboxing here, or unbagging, as you can see. See what this thing looks like. I'll do another unbagging. Warning, don't just do what I just did. You're going to slice it with a sharp knife, slice it at the edge. See if there's anything else in there. Nothing. Garbage. LISAMRC. Another angle to see the world. Kind of funky looking. There's the part number. There's LISAMRC ML180. Some warning signs. Away from the crowd. Alright, let's dig into this sucker. Some extra strong staples. Let's see what this sucker looks like. That's tiny. Garbage. Let's lay stuff out here and see what we have here. Hopefully you can see all that. So we have the main frame. That's some nicely routed carbon fiber. We'll do some tests to make sure it is carbon fiber. So it's sort of, they've done some funky routing within to minimize the thickness, but keep it thick on the areas where strength is required. So let's get the calipers out. Do some. I'm a metric guy here, so in Canada we are metric. So let's see, do this the right way around for you guys to see. So we're just a tad shy of 3 millimeters thick. See what consistency we have here. 294, 295, 293. It's all pretty good. I don't know if I'm going to be able to get in there, but I suspect that if we do a difference measurement, let's see here, a millimeter difference, so that's about 2 millimeters thick in these areas here. So there's some weight savings there. FPV camera holder there, so that would mount on the front. We'll double check that, but I think that'll angle backwards. Have some mounting posts here, aluminum mounting posts, nice red color, anodized red. Some mounting screws and some interesting looking threaded screws with holes in them. We'll have to have a closer look at that sucker. See what that's all about. I don't think I've ever seen such a thing before. Apologize for the graininess of this picture. Let's see if we can get a good look at that for you guys. So that is a threaded, looks like an M3 with a hole in it. I have to figure out what that's for. So we have a top plate here, so that presumably would be mounted as such. Carbon fibers, nice tight fitting carbon fiber. Let's do a quick check here how that looks. That would go in like that, that would go in like that, and the mounting posts would have it like that. There actually doesn't appear to be an angle for the FPV camera, so you may have to do some mods if you're going to be looking to angle your camera upwards. Actually, it's a slight angle now that I look at lining things up, so a bit of an angle upwards. But typically you mount that at about 40 degrees, and I don't think that's quite 40 degrees. So another interesting part that has come with this is PDB, power distribution board. So you would mount your battery leads here, and then your distribution to the ESCs. All 4 ESCs come out from the base here. So that, I have to double check that, but presumably would mount either on the top side, but then if you do that, you might not have any place to mount your other components, so probably the bottom side like so. Your battery leads would come around here, and your distribution would go out. You can run your wires through these corners here, or through these triangles here, into the ESCs. So have another look at see what else we have. So let's do some checks on this carbon fiber. So I've got my handy ohm meter here. For those that have never done this, you want to check the reality of carbon fiber. Usually you look for exposed carbon fiber area. I typically go with the corners of the carbon fiber. See if you can see this here. And then you find an edge, 2 edges, put the volt ohm meter on it, and you're going to look for a little bit of resistance. You'll always see some resistance, but that gives you an idea that you're dealing with real carbon fiber here. You're going to have current be able to be passed through the carbon inside the frame. So got the real thing here, guys. A little more resistance the further away we go, which is expected. So that is a genuine carbon fiber frame, and for giggles we have a carbon fiber top plate as well, and I'm not going to test the FPV camera mount because I'm pretty sure that's carbon fiber. So let's have a look and see how these motors mount. I've got some DYS 1806 motors here, 2300 kV, which would probably be the standard motor you would mount, and they're M2 screws that come with them. DOIS gives you sort of an offset motor mount. So let's see. One of the things I found with the Fee Young frame that I got recently is that they seem to make it only for the larger motors, which sort of sucks because I have these 1806s I wanted to put on it, and now I've got to find a way to get washers in place so that the cap heads don't come through the mounts. This is a good size here. They've drilled these for these M2 screws, which is nice. So you have a good firm mount, secure area for that screw, and lots of thread space for that motor to mount to. So that motor would fit somewhat like that. You can see that there. Now, some people are a bit paranoid about having, edge motor protection. I'm not so concerned about it. But you could always, if you have a 3D printer, you could always 3D print yourself some motor protection to go around this, or buy some bumpers to protect your motor, or just not crash. So, typical motors come with a fair bit of wiring. Your ESCs might be mounted here. There's enough room there that, given this equipment, you could mount a tiny FVT little b ESC here, or potentially on the underside, depending on if you're crash prone and whether you got this area well protected. You want to limit what you're mounting on the other side of your quad. I typically try to aim to mount on the top side. PDB is not so bad. You're just dealing with some wires, but you could always protect that as well with some cushion landing pads that would take some of the hit if you landed too hard or came down too hard. So now let's talk about mounting your controller. Now this one here seems to be at the standard spacing. So I've got a controller here, Flip 32 controller here. So standard sizing. I think it's a 30 millimeter unit, standard spacing for holes. But you can see there that guy with some spacers would mount quite nicely right there. I've got the headers coming straight out, but you might have headers. You might not have headers that come off to the sides. Although this has got a fair bit of space in here, you wouldn't be mounting the battery inside here. So with these suckers, you're talking spacing. It's pretty tight actually. You're pretty tight with spacing. So you would need to have your side mount headers with your controller, or you wouldn't be able to get those wires through. Obviously to the top, it would just be a bit strange there. The headers, or the AESC cables. Let's see if I got a servo cable here I can use. If you get that mounted to the top, you're gonna be bumping up against that top. You're not gonna have enough room. It's too tight. These guys here are only, I think they're just shy of an inch. Just barely. You'd be pressing pretty tight on that. So if you're ordering a controller, you're going to want the angle mount headers for that to keep that out of the way, because you're going to need to space your controller out, because if you mount that directly to the carbon fiber frame, you're going to fry the thing, right? Because you've got connectivity here. It'll conduct any of these contacts directly, so you need to have that spaced out by a couple millimeters above the base. So keep that in mind when you're setting this guy up. So I think that's about all I got here. Comes with a standard bag of all the various mounting screws, so you've got lots of screws there to mount these various guys. And these also comes with some little, let's dump these out, some smaller mounts, which presumably are your spacers for your controller, keeping in mind that these are likely, well, they are aluminum, and depending on your board, you don't want to have, usually these boards, if they conduct at the mounting point, they usually conduct ground, which is safe. But make sure that if you're mounting these guys, if you look closely here, you've got a resistor mounted very close to this guy, and if that's making contact and there's voltage passing through that, you're going to fry something. So I typically go for the plastic spacers so that you don't have any connectivity between your main board and anything it's being mounted to. It's the safe bet, so be careful about that. So we're going to, I'm going to put this thing together, but I'm not going to bore you with that. We're going to have to figure out just what the heck these things are for. Hopefully my friends at GearBest can give me an idea of that. What I'll do is I'll post back some comments in my blog, plastibots.com, about this and see where we go, and I'll also post some pictures. What I'll do is I'll put stuff together, mount these things, figure out how everything gets mounted, put it all together, see what it looks like, maybe mount a motor too, and then show what this thing looks like. It's very small. Didn't do some measurements for you guys, but I'll do some quick, again, centimeter wise, but basically center to center, 180 millimeters as it said. So this is a nice tiny quad. It's a nice little, probably a very quick little fun quad to fly. Total length to the edge of the motors is about 100, maybe 145 millimeters in width. This one seems to be a bit wider here in the back, so you're talking 160 millimeters in width. So, and just general comments about the quality. I've had a number of quad frames, and these, I'm looking very closely at the CNC work on this one, and this is very slick, very impressive quality CNC work. It's not sloppy like some of the others I've seen, where they often have the G code or whatever is messed up, or the machine is going, they've got the machine going too fast, and it ends up making some ovals in the holes because of its jitterness as it's going around making these holes. So this is well crafted CNC cutting in this on this frame. Very impressive. This is actually, you've got the shiny surface on the carbon fiber, which tends to not be conductive, but I wouldn't take that chance, because the moment you scratch it, it becomes it. This is, been machined down and would be very conductive, completely conductive. So you don't want to have any live electrical components touching any of these pieces, and frankly, let alone anything. You should just, make that a standard practice, that everything is insulated from a carbon fiber frame, or you're going to be in trouble. And also, for those that think that you might want to use the carbon fiber frame to do some conducting of let's say LED, you want to somehow use it as a ground or something to save one wire for an LED. I wouldn't do that either, because you do have internal resistance in this stuff, right? So you're going to be wasting electricity on that resistance. So it's not really, you shouldn't really use it as a conductor. It's just a frame. Strength wise, it's pretty good, some pretty good strength. It's good flex too, because you're gonna want to have this thing flex if it crashes, right? You don't want things, you snap. I guess one of the disadvantages here is most frames tend to come with separate arms, right? You crash this guy, you break an arm, you're replacing that entire frame, so you're pretty much buying the whole thing. As for pricing, I think it's a pretty reasonable price. They're about $31 Canadian for it. They have it listed as regular $85, but I don't think anybody would ever pay that much anyway. So I think they need to do some realistic price adjustment identification on their site. Anyhow, that's all I have to say. Again, it's Dave from plastibots.com. I'll post some information probably over here or over here, however it looks when it's done, and hopefully you guys can make some decisions based on this information. All right, thanks folks, take care.